And the warm today is try to solve these by hand. So let's see if you remember anything from Algebra 1 as far as just solving things straight up from algebra stuff. Okay, here we go. Number 1 today, write her down, is x squared minus 10 is equal to 6. So that's what we're going to be looking at first thing. Thoughts? Anybody got any suggestions on how we could solve this? Any clever things? Hmm? Hmm? I like that. Let's add a 10 to the other side. So yeah, if you just got an x squared thing by itself and that's all, then just get the x squared thing by itself, just like you would get x's by itself. Now, unfortunately, you have a square. How do you undo a square? What's the opposite of squaring something? Square root. Now, this is the first of about 1,000 times I'm going to say this throughout the year. When you take a square root of something, what is the square of 16, by the way? 4. Okay, so I took a square root of this side, I took a square root of this side. You have to put in plus or minus, because both of those answers, when you square them, turn out to be positive 16. 4 squared, 4 times 4 is 16. The negative version also works. So please get this in your brain right now. It'll save you a lot of headaches and lots of points. When you take a square root, don't forget to put plus or minus. Either one is acceptable. So there's your answer for number 1. X squared minus 10 equals 6. Okay, well, x is either positive 4 or negative 4. Well done on that. Let's try another one. Number 2, same kind of idea. Number 2 today was x squared minus 1 equals 0. And in the same exact fashion, if you have no x terms, there's x squares, but there's no x's. There's just this thing by itself. We'll just move the 1 over. And then again, take a square root, and the square root of 1 is 1. So, and don't forget your plus or minus. So the answer to this one is either positive or negative 1 right there. So it seems like for solving square things, if it's not too complicated, you can just move things to one side and take a square root, and that usually does do the trick. Number 3 looks about the same kind of thing. X squared plus 1 equals 0. And you go down the exact same road. Let's try to get the squared thing by itself. So you subtract the 1. And now you're about to take a square root. Now, square root by definition means the number that times itself equals that thing. So when I asked what the square root of 1 was, I'm asking what numbers times themselves equals 1. 1 does, right? Negative 1 does also. Now over here, there's no number that when you square it equals a negative. Because if you take a positive number times a positive, what do you get? Positive, right? So this isn't positive. Is it negative? No, because a negative times a negative is also a positive, correct? So there's no negative number and there's no positive number that works. There is nothing on the real number line that works whatsoever. Nonetheless, we are still going to solve it like normal. I'm going to take a square root of a negative. It doesn't have any real meaning. We're going to give this thing a name. It's a new kind of number today. It's not on the real axis. It's nothing you've encountered before. It's called I. And this thing, the square root of negative 1, is by definition what we're going to call I. It's going to allow us to solve problems that we couldn't solve before. So that answer right there is not, you're not going to find it anywhere from negative infinity to infinity. It's nowhere on the number line. We got to go to a new kind of number called imaginary and branch out a little bit in order to fully solve quadratics. And that's the point of today. Today, we're going to introduce this I thing. We're going to get comfortable with it. There's a lot of skills with it. How to add them, how to subtract them, how to multiply them, how to divide them, key characteristics. It's a lot of stuff. It's important stuff today. You're going to be working with I's the rest of the year. Hopefully, remember something about them from Algebra 1. Not. This is your chance to relearn them. The homework is due today for solving quadratic equations by graphing. So hopefully that wasn't too bad. I know there's at least a couple problems on there that had problems. So there'll be a few points given for free, no problem. This new thing we're going over today, of course, you got 2 days on it, back to the normal rhythm. So tomorrow will be a work day, and Wednesday we will continue actually applying this stuff to solve quadratic equations. All right. Notes. Make a note to yourself. There is homework. I'm kind of assumed all the time, though. I don't think there's a day where you don't have something to worry about. But 3.2 is due today. 3.3 is due on Wednesday. Then let's dive right in to things that matter. Today's topic, section 3.3, very important section today, complex Numbers, they're complex. They're not just real, they're not just imaginary, they're a mix of the two, they're complex. Found on page 161 of your textbook. So if you want to reference that, be my guest. And let's dive in because we got lots to write down today. First things first, write down this box over here. Trying to summarize what things are. Now, in our work, we just try to come across a situation where we need a square root of a negative number. And we can't think of any real number that we've ever exposed to as a child or anything in life where that works out okay. So they invent a new number. It's called an imaginary number. It's a bad name for it because then kids think it doesn't matter. Oh, it's not real. What do I care? It's imaginary. No, it's just as real mathematically as any other numbers that we've ever talked about. Very, very handy thing. Just a bad name for it. It's not real, so they call it imaginary, but it's very, very useful. By definition, that top right thing, it tells you what I means. We're going to write the letter I a lot because we get tired of writing the square root of -1. That is what I is. It's a square root of a negative number. There is no number that when squared is a negative. So we invent this new one called I in order to do so. Very important to know the first few powers of I, and that's what those 4 below it are. Anything to the 0 power is 1, including I. So I to the 0 is 1. I to the first is I. Now this third one down here, you probably want to put a star by that because you're going to use that one a lot. The one that says I squared. I squared equals -1. And that should make sense. Because if I is the square root of -1, and how do you undo a square root? You undo it by squaring both sides. That means that I squared is -1. That will come up in your work a lot, okay? You're not going to need the other stuff too much, but I squared is going to come up quite a bit. And I cubed as well, -I. That one will come up from time to time, but mostly we need I squared and that kind of stuff. So know what I is. I is the square root of -1, and I squared is just -1. If you know that much, you're going to be fine, because beyond that, it's really just working with i's like they're variables and moving them around, stuff that isn't too complicated right here. All right, let's do this one right here. Simplify this. Now, most of this work on the board is a little beyond us. I'm not sure if we remember the skill of simplifying radicals, but I don't want you to get too bogged down in this. Well, here's what I want you to focus on. This is the square root of what? A negative number, correct? That's bad. You see a square root of a negative, automatically it's an imaginary thing. So here's what I want you to get in the habit of doing. First off, you can split this into 2 parts. You can split your roots into 2 numbers multiplied together. One of the roots, I just want you to keep the number, whatever the number part was. And the other root, if it was -1, just take a square root of -1. So it's the same thing. 294 times -1 is the same thing, just broken into 2 different roots. All right. Now, here's the main thing I want you to get out of the lesson right now. What is this? What is the square root of -1? We just defined it. What's that called? It's not I squared, but it's just I. So this is an I. So I'm going to write I. I stands for the square root of -1. The other thing you're left with, that's just some weird square root of some real number. That's just normal business. So we split into 2 parts, normal business, and we take care of the square root of the negative with an I thing right there. And of course, they're still multiplied together. Now, what this is extra credit here, and if this doesn't make total sense to you, don't freak out right away, but this is what the book is doing. There are ways to simplify square roots. For example, if I take, I'm going to rewrite this one a little different. Why is this so hard? 36? Really? Okay. Now, I don't expect you to know this thing right here, but 294 is the same thing as, try to get this gist, and if you get this, then in the future, life will be better. If not, don't sweat it today. I'm going to take 294 and turn it to 2 different numbers. Trust me on this. I just checked my calculator. It's the same thing as 49 times 6. Now, why would he do such a thing? You see how this thing, we took it and broke it into 2 different parts? I can break this into 2 different parts. I can call this the square root of 49 times the square root of 6, and there's still this I out here. The reason I chose to do that is because what is the square root of 49? Is it nice and pretty? Yes, it is. It is 7. So instead of writing square root of 49, I'm just going to write 7. And then I have this leftover thing of square root of 6, and I have this I thing here that's left over as well. So that's the most simplified that they could possibly want anything right there. Honestly, I'm happy if you just get from here to there today. Okay, if you just understand that the square root of a negative means that there's an I, I'm pretty good with that. But they're starting to introduce this skill of simplifying square roots, so we might as well learn it too. And there's your answer. So your answer for this is if you simplify it, 7 times the square root of 6, and then that's still times I. Okay. And there it is right there. Let's try this one out. Simplify the square root of negative 75. So there's another example. Let's try this. Now, right off the bat, that thing's negative, right? So you can break it into 2 parts. Leave the pretty part, 75. And we're going to take the negative off all by itself, and it's under its own root because I have a name for that. Square root of negative 1 has a name. It's called I, right? So the square root of the negative 1 is I. Now, 75, here's the trick. Here's what you're looking for when you're simplifying roots, by the way. You're looking for perfect squares that go into it. Why perfect squares? Because this is a square root. So I'm going to name numbers that are squared. 1 squared is 1, right? 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And so on and so forth. These are all something squared, correct? Now, what's the biggest one you see that goes into 75? 25 does. I agree. So I'm going to write this 75 as 25 times however many times I need to multiply it by to get to 75, which in this case is 3. And the whole reason I'm doing that is because I can keep breaking these roots up. I can keep breaking them up. I can break the 25 and the 3 apart. I can break the negative apart. We can put them all in separate roots. And the reason we wanted to choose 25 is because the square root of 25 is pretty. It is 5. So the final answer to this particular problem would be 5 times the square root of 3 times I. Again, if we just called this square root of 75I at this point today, I'd be happy that we know that the negative under the square root means I. But the simplifying roots is an extra good challenge for us right there. Let's try this one out. Okay, looks intimidating. It's not that bad. So this example, we have 2 roots with negatives under them, but we're just going to do the same exact thing 2 times, and it's not going to be anything difficult. So we have the square root of negative 10 times the square root of negative 15. So the first thing I'm seeing is that these are both square roots of negatives, correct? So separately, I'm going to break this square root of negative 10 down into a square root of 10 times a square root of negative 1. Then, same thing for the square root of negative 15. I'm going to break that into the square root of positive 15. And also times the square root of negative 1. So I'm just taking these numbers and splitting them up. No big deal. All right. Now, let's see what we can do here. I'm going to lump, first of all, let's lump some things together that go together. We got commutative property. We can move things around. It doesn't matter what order I write them in. It's okay. I'm going to put the real stuff, but I mean the stuff that doesn't have the squares and negatives, together. And then I'm going to go this times this. Now, we have a name for this. This is I, right? This is I. That's I. So just like x times x is x squared, I times I is I squared. So I got myself an I squared there. Now the book is even more fancy here. There's not much we can do with this. There's no squares that go into 10. Would you agree? Nothing. 1's boring. Don't ever use 1's boring. But do any of these go into 10? Do any of these go into 15? No. So it seems like you can't do much with this, but we're going to go out in a long shot, and instead of breaking numbers apart, that's what we've been doing, right? We can break things apart. We're going to put them back together. Now, if these two are 10 and 15, then together, under the root, I can put them back together as 10 times 15 under a root, which is 150. And here we still got the I squared, which I'm going to harp on in just a minute. Now, the reason they might want to do this is because there is a perfect square that goes into 150, and it is 25. So you can write 150 now as 25 times, I believe it is 6. So I kind of lumped them back together and then rethought the problem and then broke them back apart into a 25 and a 6. I still got 25. I still got a square root of 6. And I still got this thing. And now we're going to simplify everything the best we can. Reason we did this was because the square root of 25 is pretty. The square root of 25 is just 5. So this is just 5. We have this leftover root thing. Square root of 6 is not pretty, so we have a square root of 6. And we still have this I squared thing that I've been kind of avoiding the whole way through. Now, what is I squared? I told you to star that in your list. Did you star it? It's -1, right? So whenever you see I squared, you need to replace it with a -1 every single time. And a negative times some stuff is just negative that stuff. So as complicated as that was, this answer, it turns out to be -5 square root of 6. Again, try not to get too bogged down in the magic of simplifying roots. Like all this work right here was really just a bunch of fancy work to try to simplify the root. More importantly, did you see that this square root of a negative had an I in it right there? Did you see that this square root had an I in it? If you saw that, then you're probably in good shape for today. And that's kind of all there was to that. All right, moving right along. Let's see what else we got. We got lots of things to get through today. Let's actually use it to solve an equation now. So here we go. X squared plus 81 equals 0. So just like the warm-up, what we're going to do on this one is we are going to try to get the x squared thing all by itself. And then we're going to try to solve for it. So here we go. If you subtract 81 from both sides, you'll have a -81 on the right. And thinking ahead, there's going to be some imaginary stuff because you're about to take a square root, correct? And square root of a negative automatically means there's going to be some kind of adjunct, but one thing at a time. We'll take the square root of this side. Square root of something squared cancels out. That's the point of it. On this side, you're going to take a square root of this stuff, and I'm going to keep harping on it. Have I already beat it into your brain yet? What should you do when you take a square root? Put a plus or minus. Cannot forget that. You will miss half of your answers throughout the life because you're going to think it's just positive something. This could be negative something too. Now, they gave you a softball here. We're going to break this into 2 parts, 81 and a negative, because the negative has a name. But they gave you a softball because 81 is easy. What's the square root of 81? 9. Okay, so I'm not going to write square root of 81. I'm going to write 9. And I'm not going to write square root of -1 because I have a special symbol for that. It's called I. So there are 2 answers to this. They're not real. You would never see this cross anywhere on the axis. If you graph this thing, you would see no real spots. That makes this 0. Nonetheless, there are imaginary spots. They occur at +9i and -9i. So there you go. Okay, take a minute, write down this definition real fast. Not the whole thing, but maybe just a complex number is something of the form a plus bi. A complex number is a mix of some real stuff and some imaginary stuff. It's a nice little cute mix. Something like that, a plus bi. A and b are just normal numbers, nothing tricky on those. Always has 2 parts, and you want to look at them very separately. It has a real part, just the first part, just a number, just like you've been dealing with your whole life, anything on the number line from negative infinity to infinity. It's got an imaginary part, and that's the number that's attached to the I, so it makes perfect sense. Examples, maybe 7 plus 8i. That's a complex number. It's a mix of real and imaginary stuff together. That's what makes it complex. It's not simple. -1 minus 3i. There's another example. As long as I got some real and some imaginary stuff, I'm good. It could be any numbers at all. Doesn't matter. As long as there's some real and some imaginary, you have a complex number. And what we need to learn how to do now is simplify complex numbers to the best of our abilities. Just so you know, this probably won't be on your test or anything like that, but we've talked about different kinds of numbers, natural numbers and whole numbers. So here's what you need to think in your mind when we're dealing with these things, okay? Everything you've ever done so far is a real number, okay? That's everything from negative infinity to Infinity. That's the normal business we've always done. Completely outside of that world is this world called imaginary numbers. Okay, so it's like two separate dudes, real stuff and imaginary stuff. And together, if you put them all together, some reals and some imaginaries, like we just talked about, that would be called a complex number. So they seem like they have nothing to do with each other. They're actually intimately related on a deep level, but we won't get to that. Just be aware that how that thing structures. Now, let's talk about how to actually do some basic operations. Now I'm talking about the basic four: add, subtract, multiply, and divide with complex numbers. I got a formula up here. It looks really complicated. I probably wouldn't even bother writing it down, honestly, because it's just common sense. Same with the multiplication. Basically, you're just doing what you always do with numbers. You're adding like terms. You're subtracting like terms. That's what you do with addition and subtraction. Multiplication, you're just distributing out, foiling, if you will, how things work. So I think it's actually a bad formula. I would not write it down and try to memorize it. I would just try to understand the process because it's so much easier than all that. So long formulas there. Examples will do far more justice for this thing than that will right there. And let's just dive into an example with it right now. All right, here we go. Example. I'm going to give you a complex number. So 2 plus 3i, that's complex. It's you know, here's some real, here's some imaginary, it's all mixed together, it's complex. Here's a complex number plus, I'm going to add another complex number. How about 4 plus 8i? Now my parentheses are useless right here. The only reason I put them there is to lump them together. Here's a complex number, and here's a complex number, but they really don't do anything because there's this plus in the middle. I'm just adding things up. Now, I want you to pretend that the i's aren't there for a second. There's no I stuff. There's no I stuff. What do you see? 2 plus 4? That's the real stuff, right? This is real and this is real. Add the reals together. 2 reals plus 4 reals is 6 reals, right? And if the i's were x's, you'd know exactly what to do. If I said 3x plus 8x, what would you tell me that is? 11x, right? Well, if I got 3 i's plus 8 i's, I have 11 i's. So you're really just combining like terms. If there's real things, you're adding them together. If there's imaginary things, you're adding them together. And that's kind of all there is to it. Same thing works with the subtraction. So let's say I had 6 minus 7i minus, now this time this parenthesis actually means something because I'm subtracting this entire thing. 8 plus I or something like that. So here's a complex number minus another complex number. There's 2 ways to go about it. First, like anything, if you see a negative in front of a couple things, you can always distribute the negative in, correct? I would strongly suggest you do that. So this first one, it was already positive. That parenthesis really didn't do anything. It was useless. But the second one, I got this negative thing. So if I distribute in negative 8, and then negative times I is just like negative times x. It'd be negative x. Well, this would be negative I. And then normal business. Put your like terms together. You see some real stuff? I see some real stuff. I see 6 minus 8, right? That's just negative 2. As far as imaginary junk goes, I stuff, I see negative 7 somethings minus 1 more something of it. That'd be negative 8 somethings. So there we go. If you didn't like the distribution, you could have just done it all in your head in the beginning. Like, see the real part here is 6, right? Real part here is 8, right? 6 minus 8 is negative 2, right? Oh, here's the I stuff. Negative 7 minus 1 would be negative 8. So you can do it right in the beginning, or you can distribute it out. It doesn't really matter as long as you don't jack it up. And that's all there is to adding and subtracting. Do I need to do more examples of that? It's pretty straightforward, I think, don't you? All right, let's do multiplication now. So I'm going to go back and do the exact same example. 2 plus 3i, only this time I'm going to multiply it by 4 plus 8i. And don't let the new stuff confuse you. If I gave you this and said distribute, would you know what to do? Hopefully you take every single one, FOIL it out, right? Because that's how you do when you have a binomial times another binomial. I got to do this times this, and this times this, and this times this, and this times this. That's how it works, right? It's no different here. So just because they're i's doesn't mean it's going to be any different of a process. So we're going to distribute this stuff out. And here we go. So first things first. 2 times 4. Well, that would be 8, correct? Score. 2 times 8i. Again, if it was x's, you'd tell me 2 times 8x would be 16x. So 2 times 8i is 16i. So 16i from that distribution. Then to the next person. So we got 3i times 4. That would be 12i. And be careful on this last one. This times this. Well, let's just do the things we know. What's 3 times 8? It's 24. And don't forget that you have an I times another I. And just like an X times an X is X squared, I times I is I squared. And this is exactly why I had you star what I squared was in your notes, because it's going to come up. Anybody know what I squared is? It is -1. Outstanding. So I'm going to rewrite this, but instead of writing I squared, I'm going to write -1. You see I squared, you have to, that turns back real. There's no i's anymore. I squared doesn't have any i's. It's just -1. Isn't that cute? And then after that, you're just going to put some like terms together and clean it up and be done. So first things first, over here, I see this is -24 now because times the -1, right? So this is -24 plus this 8 in front. That would be -16 when you put those together. So we took care of the 8, took care of the -24. We have these imaginary things in the middle still, and we're going to add them up. They're like terms, they're I stuff. 16 somethings plus 12 somethings is 28 somethings. So plus 28 i's in this particular case. And that's my answer all simplified down. You start with a complex number, something with real and imaginary. You do some work, and what do you get back out? Something that is complex again, real plus imaginary. That's pretty much all there is to that. Let's try another one of those. Three plus 4i times 3 minus 4i. Well, here we go. Nice and slow. 3 times 3 is 9, right? 3 times -4i would be -12i. So that's from the 3 distributed to both of them. Moving right along to the 4i. Positive 4i times 3 would be positive 12i. And lastly, 4i times -4i. Well, just do the number parts first. I got positive 4 times -4. That would be -16, correct? But we also have this I times this other I, which is I squared. And that should raise some red flags right there about what I squared is. Because just like the last problem, instead of writing I squared, write -1. I squared is -1. That's extremely important to know. Now, while we're at it, look at these two middle terms right here. You got -12i's plus 12i's. They just cancel, don't they? Well, I don't need to write that then. But over here, I got -16 times -1, which is positive 16. And finally, 9 plus 16 turns out to be 25. So the answer to this particular problem is just, there is no imaginary stuff. It's just 25. And that will always happen when you have, what's the difference between these two numbers I wrote on the board? What's the only difference between them? This one's positive and this one's negative. If that ever happens, you will get out a nice clean number. In fact, we need that fact that if you take something like this times something like this, you will get out a nice clean number. So we're going to have to give that a name. We're going to define that. And here's what I'd like you to write down here down the bottom box. These things are called conjugates of one another. A conjugate is the exact same number. In our case, it was 3 plus 4i. That was the first one I picked. But they just switch the sign of the imaginary part. That's all it is. So the conjugate of 3 plus 4i would be 3 minus 4i. The conjugate of 8 minus 9i would be 8 plus 9i. So a conjugate is a fancy word for the exact same number with the sign of the imaginary part flipped right there. The reason I have to introduce this idea is because we do need it for division. To divide two complex numbers, we're going to have to use this fact that if I take a complex number times its conjugate, you will get out something pretty. We're going to use that to do division. Much like the addition, subtraction, and multiplication formulas I gave you, this is a big, ugly mess, and I would not memorize that. I probably wouldn't even bother writing it down there. I would understand the process. I'd probably write down that thing in parentheses, though. Multiply the top and the bottom through by the conjugate of the bottom. That's the strategy to get through this. That's the concept. I'm trying to get through this class. You understand the concepts. I know how to get from A to B. So for division, what you're going to do is you're going to take the fraction, you're going to multiply it on top and bottom by the conjugate of the bottom. That will be your strategy. Besides that, it is fraction work and multiplying straight across and some patience. It's not that bad. But for addition and subtraction, just combine like terms. For multiplication, FOIL it out. Don't forget I squared is -1. For this, you have to just put it in your brain somehow. How do I divide complex numbers? I multiply the top and bottom by the conjugate of the bottom. So I don't want to do that example. It's boring. Let's do this. All right. Let's talk about dividing complex numbers. So here's a complex number divided by another complex number. And here's your strategy. The only thing you should have written down from the last slide, besides what a conjugate even is how you divide them. You multiply the top and bottom by the conjugate of the bottom. Conjugate of the bottom. Now, here's the bottom, right? Conjugate just means what? The exact same thing with this sign change. That's all conjugate means. So I'm going to multiply the top and the bottom by this thing's conjugate. This thing's conjugate, 5 minus 6i, is going to be 5 plus 6i. That is a conjugate right there. But just like any fraction, if you're getting a common denominator, getting a whatever, you got to multiply the top and bottom through by something, right? So you have to do it on the top too. You can't just do the bottom. You have to do the top and the bottom. All right. Now, never forget your basics, okay? The basics, they're basics because they apply no matter how high you go. How do you multiply fractions? Straight across, right? So that means on the top, I need to take this complex number, this whole thing, times this other complex number. And same thing on the bottom. I'm going to have to take this entire complex number times this complex number on the bottom, which is a lot of distributing and cleaning things up. But it's going to work out okay. Let's start on top. Here we go. This thing times this thing, I have to FOIL it out. I have to distribute this thing out. So here we go, nice step at a time. 3 times 5 would be 15. 3 times 6i would be 18i. And the 3's done. Now we'll move on to the 4. 4i times 5 would be 20i. And lastly, 4i times 6i, well, 4 times 6 is 24. And I times I literally means I squared. So I'm going to write I squared. Don't forget to have the I squared on the end. Now we'll need to clean that up, but let's just go and get the bottom over with too, because we've got to do the exact same thing on the bottom, right? We've got to multiply this times that on the bottom. So again, we're going to distribute this thing out. And here we go. 5 times 5 is 25. 5 times positive 6i would be positive 30i. And the 5 has been distributed to both dudes. Moving right along to the negative 6i. Negative 6i times 5 would be negative 30i. And the last couple pairs, negative 6i times 6i, well, negative 6 times 6 is negative 36. But you got an I times an I also, which is I squared. So that's what that thing kind of looks like. Now it's gross as heck. So let's take a minute and actually clean some things up. First thing I see is there's I squared. What's I squared again? -1, exactly. So we're going to replace all the I squared with -1. So on top, we got 15. While we're at it, are there any like terms you can put together? You can always put like terms together. I see 18 i's plus 20 i's right here. Why don't we just save a step and call that 38 i's? Because that's what 18 plus 20 is. And then over here, like you were saying, now if you're getting good at this stuff, and I beg you to kind of go slow, first I would say I squared is -1. Then what's it say? -1 times 24, which is -24. So if you just want to skip a step, when you see 24i squared, you can call it -24 if you want to do that. And there's the top. Now the bottom is pretty. Watch the magic. Look at these two middle terms. What do they do? That will always happen. That's why you are multiplying by the, what's the word when you change the sign? What's the word when you change the sign? Look it up. I got time. What's the word when you change the sign right there? Conjugate, right. If you take a complex number times its conjugate down here, those I things will always cancel out. And the only thing left is, while we're at it, what's I squared? So is that really negative 36? No, now it's plus 36. And you see the bottom is going to be nice and pretty. I don't mean it's like a pretty nice number like 2 or something like that, but it's real. 41, what am I talking about? Oh, 61. Bottom turns out to be a nice, pretty 61. That is cute. On the top, we still got a little cleaning to do because I can do 15 minus 24. 15 minus 24 is negative 9. And try to always write in that order. Put the real stuff first and the imaginary stuff second. That's the classical way to go do it. So here's your answer. Negative 9 plus 38i all over 61. The point of doing this is to get the bottom to be pretty. You have a complex number divided by a complex number. You don't want complex numbers on the bottom. So you have to go multiply by the conjugate to get out to 61. Let's try another because that's a pain in the butt. How about 1 plus I all over, I'll make it 4 plus, I don't want to confuse you. 4 plus I all over 1 minus I. And your strategy, again, you either know what to do or you don't. You have to multiply the top and bottom by the conjugate of the bottom. You want the bottom to be pretty. That's the point. That's why you multiply by the conjugate of the bottom. If you want to make the top pretty, you multiply the top and bottom by the conjugate of the top. But that's not our goal. Our goal is to make the bottom pretty. So we're going to multiply the top and bottom by the conjugate of the bottom. What is the conjugate of the bottom? 1 plus I. Very good. So I'm going to multiply this on top and bottom by 1 plus I because I know when I multiply the conjugates on the bottom, they will turn to something nice and pretty. But we got to work for it. So there's a lot of distributing, a lot of patience and things like that, and just nice slow foiling. Here we go. On the top, here we go. 4 times 1 is 4. 4 times I is 4 times I, 4I. Distributing the I in, I times 1 is I. And what's going to come next? I squared? Why don't I just save a step? What is I squared? Negative 1. So instead of writing plus I squared, I'll just write minus 1 because that's what I squared is. Save myself a step. You know what you're doing, it will go a lot faster. Down on the bottom, same logic. We're going to go distribute this out. 1 times 1 is 1. 1 times I is I. Moving on to the negative I and distributing that. Negative I times 1 is negative I. And then you're going to have a negative I squared. And I'm not going to do too many steps at once. I'm going to take a moment there. Negative I squared, I'll just write that. But what is I squared? Again, it's negative 1, right? So what is this really? It's not, it's negative negative 1, which is just plus 1. Okay, so we can just write a plus 1 on the bottom. Speaking of, if this is 1, and this is 1, look what happens with the conjugates. What always happens with the middle things, they cancel out every time. There will not be any I stuff left on the bottom. That's the whole point. So you have a 1 plus 1 on the bottom. On the top, just combining some like terms, I see a 4 minus 1. That's 3, right? And I see 5 i's all together on top, 4i plus an I. So that's 5i. And the only other thing to do is simplify what 1 plus 1 is. So your final answer is 3 plus 5i all over 2. And we've accomplished our mission. Our mission is to make the bottom pretty. Bottom is nice and pretty. It's not got any i's and anything like that. That's why we're multiplying the top and bottom by the conjugate of the bottom. Very, very important. All right, now they're going to throw some other kind of problems at you too. This is very, very easy here. I just want you to see what they're doing. They're saying this complex number, which looks confusing, is equal to that complex number. The only way they're going to be the same is if their real parts are the same and their imaginary parts are the same. So over here, what's the real stuff you see? I see 5x minus 17. There's no i's with that, right? 5x minus 17. What's the real thing you see over here? 13. So 5x minus 7 must equal 13. You could solve that real quick, right? 5x minus 7 equals 13. Add the 7 over. 5x equals 20. X equals 4. It'd be very easy to figure out. What about the imaginary stuff? How many i's are over here? I see y plus 4, correct? Well, how many i's are over there? 11. So y plus 4 must equal 11. So if y plus 4 equals 11, then y must be 7 if you subtract 4 from both sides real quick, correct? So those aren't tricky. I'm not going to make you go through them, but in case they try to compare things, what are you doing? You're comparing the reals to the reals and the imaginaries to the imaginaries. Remember that. You'll be just fine. And nothing will be too tricky here. Let's do one of their problems where they want us to simplify something. We can't practice this skill enough, dividing them, because dividing's got every skill in it at once. Adding, subtracting, multiplying, and dividing. So let's try this problem. 5i over 3 plus 2i. Same thing we've been doing. We're dividing two complex numbers. And the thing that should guide you when you're dividing two complex numbers is you want to multiply the top and bottom by the conjugate of the bottom. That's just what I do. That's just the procedure. You either know that and you do it, or you don't. You just mess up the whole problem. So the conjugate of the bottom would not be 3 plus 2i. It'd be 3 minus 2i. And I have to put that on top and bottom. You can't just put it on one part of the fraction. It's got to be the same thing on top. Like multiply by 5 on top and bottom. Same thing. All right, so we got to go multiply fractions, which means multiply straight across. So it means this thing times this thing. And on the bottom, those two things will be multiplied together as well. Now, top ain't so bad, because this doesn't have two things, does it? It's just 5i. So we're just going to distribute the 5i into both of those and be done. 5i times 3 is 15i. 5i times negative 2i, I'm going to go nice and slow. 5 times negative 2 is negative 10. I also got an I times an I, which is our friend I squared, which we'll clean up to negative 1 in a second. Down at the bottom, they're conjugates. You know it's going to work out pretty. That's the point. So let's distribute this part out. 3 times 3 is 9. 3 times negative 2i would be negative 6i. And then moving on to 2i, distributing that, 2i times 3 is 6i. And 2i times negative 2i would be negative 4 from the negative 2 times the 2. And then you got an I times an I, which is an I squared. And simplifying things, you know I squared is negative 1 on top. So on top, 10i squared. Well, if it's negative 10i squared and I squared is negative 1, well, then I got a negative times a negative, which is a positive. So I got plus 10. This whole thing is plus 10. That's negative 1. Negative 10 times negative 1 is positive 10. On the bottom, as promised, those middle things will go away with the conjugate. That's why you're doing that. And the only thing left would be a 9, but same logic. If this is I squared, this is a negative, right? So I got a negative times a negative, which is a positive. So it's 9 plus 4. And then putting things in a normal order with the real stuff first and the imaginary stuff second, I'm going to write the top as 10 plus 15i. And the bottom, 9 plus 4 is 13. So that's really all that we had to do right there. And that's got every skill in it. Okay, the division. So if you can remember the division one, what do? Multiply top and bottom by the conjugate at the bottom, right? You remember that. And you can do fraction work, multiply straight across. Remember, I squared equals negative 1. You'll be fine. And you can FOIL out anything else from there. So there's your lesson over section 3.3. Homework will be due on Wednesday. You have all class tomorrow to work on it. And finish up 3.2 and start on 3.3 tonight.